Welcome friends, I am Tanmay and welcome you all in my channel Chemistry, the Mystery of Molecules. This is a continuation lecture of Cannizzaro reaction which in case the basic chemistry part I have uploaded in the previous video, and means basic chemistry means understanding mechanism like that, and this is the examples. So I suggest you please first read that if you didn't have read that. So please read that first. After that come here, because there you will clarify your knowledge about basic concept and you will evaluate your knowledge here. And one thing is that will be a practice whether you have learned properly or not. Okay, fine. And this is the continuation thing. And in case of I am trying these videos for means the first part for high school students, second for this examples part for mainly B.Sc like that or M.Sc higher studies. But this Cannizzaro reaction I suggest the student from high school, please read it, it may be useful for you. And finally, so this is, and you will have the videos for important for school student in a separate playlist. I have made a separate playlist named as for 11-12 high school student. So whatever in that playlist, this is my recommendation for you. It is, I believe it is important for you. So read that. And if you want to read more and more further advanced, you can read other videos in my channel. Okay, so let's start. So here, Cannizzaro reaction, and in Cannizzaro reaction, this is a disproportionation reaction, means one part is oxidized, one part is reduced. I have explained this in first part. So actually 50% of each product, if I consider 100% conversion of that parent aldehyde, means parent aldehyde having no alpha hydrogen, please keep it in mind, no alpha hydrogen, and then 50% each product is expected, maximum. Okay, so let's discuss. So our first condition is no alpha hydrogen, means we can say no alpha hydrogen. So this is the primary condition for this Cannizzaro reaction. So now let's discuss about formaldehyde, simplest aldehyde, no alpha hydrogen. So what formaldehyde does? Formaldehyde gets reduced under this reaction condition and it produces methanol CH3OH, and what part is oxidized that produces formate, and after workup it is produced formic acid. Fine, formic acid we have done. What is about thiophene? Similar, means this, if I am not writing, this thiophene also produces this alcohol. If it is thiophene, and another part is oxidized to corresponding, I should say minus, that's better because reaction medium I have said only alkyl. Okay, and the interesting part is both, means in case of furan will also follow the same thing. So in case of sulfur oxygen both is similar, means oxidation reduction possible, Cannizzaro reaction. But if it is a pyrrole derivative, means pyrrole aldehyde, then it will not undergo this Cannizzaro reaction. Why? Because this proton is abstractable in presence of this base. So what it will produce? It will produce this N minus CHO. Okay, and another thing, this N minus donates its electron through this in this way, and the electron deficiency of this carbonyl-carbon decreased. In previous video I have explained about one example, N-dimethyl. This is N-dimethyl CHO. These don't undergo Cannizzaro reaction. Why? Because of the donation of this nitrogen lone pair into this benzene nucleus in this way. This and this bond opens up. So in this, similarly this thing happened. That's why only this pyrrole don't undergo Cannizzaro reaction, because of the deprotonation which increases and anion formation which decreases the electron deficiency of this aldehyde group. That's why it doesn't undergo this aldol. This is an exceptional example. Keep it in mind. Okay, fine. Now let's come to the second example. You can see these also do not have any alpha hydrogen. This trimethyl acetaldehyde also do not have any alpha hydrogen. So what happens? this can also undergo reaction, Cannizzaro reaction. But interesting point, why I have chosen? Because this tertiary butyl group is a very bulky. We observe that if a carbonyl group is attached to a tertiary butyl group, it's due to bulkness, the incoming nucleophile can't attack. But remember, here hydride can do it. Okay, hydride can attack this and ultimately undergo reduction to this alcohol. This acid is not an important factor. First of all, this alkali attacks. Fine. It is expected the reaction rate will be little slower. But this is also possible. So don't get confused that okay, along with an aldehyde there is a tertiary butyl group, so it will undergo, it will not undergo because of bulkness. It is not the fact. This reacts. And another thing, that it both nucleophilic attack of this hydroxyl as well as hydride. Hydroxyl produces this and hydride produces this alcohol. Both happens. Okay, fine. Now the next example is, you can see this has an alpha hydrogen. So as the basic condition of this Cannizzaro reaction that it should not have any alpha hydrogen, but this has an alpha hydrogen. So it is expected that this should not have any alpha. So it is expected that this material will not undergo this reaction, but it undergoes. Why? Because if this alpha hydrogen is there, what is the chance that this can produce this carbon ion? This can produce this carbon ion and undergo aldol condensation. But it has a problem. Problem because this dialkyl, this dimethyl means this tertiary carbon is not, due to the bulkness, is not sufficiently active to participate aldol condensation. Means another molecule of this aldehyde, this carbon ion can't come and attack. Not possible. Okay, due to this bulkness factor. But this aldehyde is there, and as I told in the previous example, in spite of having the tertiary butyl group, this can undergo this Cannizzaro reaction. So this happens for this, and actually instead of aldol, these undergo Cannizzaro reaction. But twist is there. This is an exception. It is true, it's happening, but that is not happening so smoothly. Means, what do I mean? You can see the temperature value. Previous case, all the reaction happened under room temperature, but this needs relatively high temperature. Okay, so keep this example in mind. So the next example is about glyoxal. You can see this glyoxal means it's a 1,2-dialdehyde, means two aldehyde in the same molecule. Previously we have observed that two aldehyde means different two molecule reacting. One is getting oxidized and one is getting reduced. Now the two reactive center is in the same molecule. Question whether it will do intramolecular or intermolecular. Means, what do I say? If this is do intramolecular, then one part will be oxidized and one part will be reduced. So what we can expect is one part will be oxidized to this carboxylate sodium salt. Oh, okay. If I write H3O plus, keep it in mind. If I write workup or H3O plus, it should not be minus. It should be carboxylate. So one part this, and this is called glycolic acid. Okay. So this, and it produces this in spite. So this reaction proves this happens through intramolecular fashion, not intermolecular. How it happens? So actually this glyoxal remain in this position because this dipole moment, carbonyl has a dipole moment delta plus, delta minus, that's why this direction, and this has a this direction. Two are almost opposite to each other, consequently they cancel or nullify each other. So relatively stabilized due to dipole moment compared to the steam version. Okay, because here both dipole moment in the same. So if you do the vector calculation, net dipole moment is in this direction. Fine. So after that, what happens? Now this is a electron deficient, so this alkali will attack, and alkali attacks this position. So what will be the product if alkali attacks here? This will be OH. I have explained this mechanism in details in the first video. If you are feeling that still you are doubt or confused, please read that first video. It will be helpful. So this, after this will be O minus, fine. After that, what will be? It will push that electron, and if it's pushed, this hydride will migrate this position and will open up. So consequently, this part, this hydride is eliminating from this. So this part will be oxidized, this part will be reduced. Means, what do I mean? So the above part will be oxidized, means COO minus, and the below part is reduced, means CH2OH. Okay, fine. In this way, this reaction happens. So we have understood this example. So similarly, instead of that, if we take this glyox, means phenyl glyoxal. So how this material could be obtained? As a remembrance, recalling of your knowledge, I am saying, if you do the ozonolysis of this carefully, if you do the carefully ozonolysis of this, what will produce? These will break, these will break. I told that one oxygen will attach here and one will attach here, one will attach, one will attach. So this molecule will result this part plus this is a glyoxal, this is aldehyde, this is aldehyde, along with this one, that is glyoxal. So keep this thing in mind, and since these two aldehyde attached to this is not that much active for ozonolysis compared to the parent naphthalene, because naphthalene is electron rich. Okay, so don't get confused. Okay, fine. So we have discussed this. So now if we take this is producing a different product. Question why? Let's come to the dipole point of view. In case of glyoxal, it has a free rotation, means this bond could be rotated freely. That's why it undergo transorientation. But these do not have any rotational freedom because it is directly attached to this benzene. So not rotational freedom is not possible. So what happened? Then it does reaction. It doesn't mean that it will not do reaction. It will do reaction. So this is the hydride. So first alkali attacks here. Alkali attacks here, and means one part will be oxidized, one part will be reduced. I have explained in the previous example. Same phenomena will occur here also. So we can say this is COO minus and this is OH. Fine. Now, sorry, not OH. This should be CH2OH. Okay. Now the twist is that if you check this example, here it is locked, and due to the ring, previously there was a disadvantage of dipole, now another advantage is there because in a scene orientation. So what can happen? So, and if you check the number, this is 1, so this is 1, this is 2, this is 3, this is 4, this is 5. Why I am checking this? Because after acidification, this charge will vanish. Means this is what of UCH2 plus this charge will vanish. Okay, definitely fine. Now there is a chance of lactone formation. Hydroxyl group is there, alcohol as well as carboxyl. So lactone formation chance is there. So under acidic condition, this can undergo lactone formation, ester formation. So it will attack first, it will open up. So ultimately what it will produce? It will produce this diol and CH2 here. This is the oxygen. After attack it will be positive charge, so it will remove the proton minus H plus. So this is fine. Now medium is acidic, so this could further be OH2 plus. So OH2 plus can leave, and for this purpose when it leaves it can push electron and stabilize the carbocation. So ultimately what will be produced? If it leaves, we can check stepwise positive charge. Then if it provides this electron and forms a double bond, what will be the product? So this will be this with formal charge on oxygen, and if this removes the proton means formal charge and this hydrogen, then the product is this one. So what is this? This example is first Cannizzaro, second intramolecular cyclization, or more specifically we say lactone formation. Lactone formation. Why I am saying lactone? Because means cyclic esters are called lactone. Means you can say ester formation, that is also true, but this lactone word is little bigger. It will show that you know something more. And I also feel that during classes, during means your school or class, if you say such type of word, your teachers get little more impressed. Why? Because that teacher, he or she think, okay, that person knows, have read a lot. So it is a strategy. Another thing in your viva, if you say, your examiner will be impressed. Oh wow, this student knows a lot. So that's a good. Okay, let's discuss another example. This is a dialdehyde, but previously I have taken glyoxal, which was symmetrical, means both are same, but here it is not same. Glyoxal and these both are symmetrical, but it is not. One side is phenyl, one side. Now question, there is a chance both sides can be attacked by the OH. Okay, so where OH will attack? the OH is a electron rich, so it will attack that position which is more electron deficient, means this carbon or this carbon. So if we compare the electron efficiency, this is a benzene, so if I draw it properly, this is benzene, means this, so it has a resonance, means pulsar effect, that it can push its electron, so in this way, and decrease the electron efficiency of this carbonyl carbon. But compared to that, there is no that type of hydrogen. It's a benign, you can say, no positive effect, no negative effect. Apart from that, this is relatively bulky, this is smaller, so what can happen? Hydroxyl will attack here. Okay, so if hydroxyl attacks here, this, so what will be, this will open up, so what it will produce? It will produce this O minus, this is OH, and this is hydrogen. Now it can push and this hydride can attack here. So what will be the product? So this part will be one H, CHO minus, and another thing, this side is OH, and this is alkoxide, this is, so they will exchange their proton, and after what will be, this is, and this is called mandelic acid. So keep it in mind, this is conceptually important because you have to decide which center will attack. Previously you can do it blindly, but right now not. So please keep this example in mind such that you don't end up with this mistake. Now we are going to explain the last example, and I guess you please to observe the example and think, because this example is a little tricky. I believe it's a little tricky for you. Why? Because you can see this is an aldehyde. This is an aldehyde attached to a benzene moiety, and this is attached to a benzene moiety, but along with that one NHCOCH3 is there. Okay, this is the twist, because in case of base, in terms of base, we can think that okay, directly this will undergo this to form this alcohol or carboxylic acid, whatever, and this part will remain same. One thing possible, another thing that it will not happen. Why? Because this nitrogen is attached to both two group. What do I mean? This nitrogen is attached to a benzene, means a aniline type derivative, so it can donate its electron in this ring also. Another thing, instead of that, it can donate here also. So in this way, this nitrogen, availability of nitrogen is more, lone pair is less. Another thing, this could be abstracted by this alkaline condition. So if it is abstracted, what it will produce? If it is abstracted, then it will produce a corresponding anion. And we have observed in the first example of pyrrole aldehyde that it do not undergo Cannizzaro reaction because of this negative charge, means electron delocalization into this. Along with that, we have example that NN dimethyl 4 position para NN dimethyl benzaldehyde, that doesn't undergo because the nitrogen delocalizes lone pair into the benzene nucleus, reducing the electron deficiency. So this is possible here also. So it will not undergo in this way. So question, there will be any reaction or no reaction? That is the most important question. So let me tell you, there will be a reaction. What? Why? Because if this is also means possible, means it will be abstracted and remaining equilibrium, possible. Another possible, that here there is a CH3, and it is true that if you consider this like a simple ketomethyl group, for example, let's talk about as this acetone, it will not be that much acidic because these do not have that much significantly pulsar effect, but this nitrogen have. It will not be that much, but it has a sufficient acidity. So this can undergo enolization. Okay, and the equilibrium will prefer to remain in the left side. In aldol condensation, I have explained this thing in details. Please go through that, I suggest you, because it will be helpful for you. So this is CH2 minus, the negative charge on that, because this is CH2 and one proton here, that could be enolized, and this is a base, so base catalyzed enol formation. Equilibrium will be less, it's true, but this. And another thing, right now this form, and what can do? This enol can attack here, and how to decide that? whether it will be able to attack or not. Let's count the number. So as usual, when from a acyclic compound to a cyclic compound is produced, I always suggest please follow this numbering strategy. It will reduce the chance of your mistake. Okay, so let's count. For example, this is 1, 2, 3, 4, 5, 6. So if this carbon attacks here, it's a 6 member. First point. Second point, aldehydes are less bulky, and we know that compared to aldehyde, ketone, aldehydes are more reactive because this bulkness and this phenomena could clearly be explained using Barghettini's trajectory. I have made a dedicated video on Barghettini's trajectory. Please go through this. So after that, this will attack and this will open up. So intramolecular aldol condensation. So this is O minus and our alkaline condition. So that's why I am writing O minus. This is hydrogen is here and this is the CH2. This. Okay. So after that workup is written. So what will happen? After workup, it will be first. It will be protonated. OH. Fine. This is CH2. This is O. Sorry, this should be a hydrogen. Fine, nitrogen NH. So this, now you can see right now it's a workup means H3O plus means acidic condition. Okay, so what will happen? This will be protonated. This, and under acidic condition, elimination of hydroxyl, that is you can think that formation of alpha beta unsaturated compound under acidic means acidic condition, because under acidic condition this become a good leaving group. So if it leaves, so what will produce? It will produce, this is NH, this is double bond O. So it will produce a carbocation here, and how this carbocation is stabilized? Because this is a benzylic one. Fine. Now there are two hydrogen. So this solvent molecule H3O plus water can act as a base and abstract this, and this will come here. So what will produce? In this way it will be converted into, this will be a CH and this is a double bond. Okay, now you can see this is conjugated system. This is completely a very good conjugated system from here to here through this double bond, and this is Na, this is O. So this is a amide type. It can undergo tautomerization. What type of tautomerization? That is a keto-enol type tautomerization. This is right now in enol form. It could be converted into keto form. So what could mean? Sorry, it is in keto form. It could be converted into enol form. And this is double bond, so proton is shifted from here to here. So in this way this product will be produced. So what is the product? The product is this one. So I believe it's a tricky example. I always suggest you don't memorize anything that okay, aldehyde, alkali, then there will be Cannizzaro. Always think what are the other functional group present in the molecule, and in this way you can end up with right question. In exam, easy examples are not given. I have observed. Only difficult are given. So if difficult examples are given, then you have to encounter all the factor, all the reactive site, all the functional groups. Then only you can conclude what will be the product. So thank you everyone for listening. And next video I shall discuss about cross Cannizzaro reaction. So you can see two different aldehydes reacting to produce a particular product. I believe this will be important for school student also. Please see that, and please see the playlist also. Okay. So this is the end of the discussion. Thank you for listening. If you like my teaching, please give a like, share this video among your friend, and subscribe my channel Chemistry the Mystery of Molecule, and please press the bell icon to get the notification of every single video I upload. So see you in the next video.